into the world of space exploration with you all today. So rockets and robots. I'll be talking about some of the amazing missions that launched this past year, including the Perseverance rover to Mars, which launched back in February, that some of you guys might have seen, and the asteroid return mission OSIRIS-REx. I'll be drawing back the curtain on how we actually design and test robots to explore every planet in our solar system. And I'll also be talking about some of the very cool recent developments that we've had with human spaceflight and astronauts. So throughout the talk today, I'm going to be asking you guys questions that I hope you answer in the chat. So please speak up there. Please let me know your thoughts. At the end, I'll be answering your questions. But yeah, let's dive right in.
I can't chat.
You can't chat.
It doesn't work for me.
Wow, look at that robot.
Yeah, you can also use your microphone if chat is working for you. So yeah, we're going to be seeing lots of cool robots. So first, I want to give a little bit of an intro to me. So I'm currently working.
Do you know Elon Musk?
All right, I have actually met him. If we can hold on to questions to the end, though, we can make sure we can get to all the good stuff, but I can also answer questions about Elon later. So yeah, I'm currently working as a mechanical engineer for MIT Lincoln Laboratory in support of the NASA Artemis mission. So this mission is going to be sending astronauts back to the moon in the next few years. So that's pretty cool. Before that, I was at SpaceX, Elon Musk's company, working on the Starlink mission, and that was to provide global internet. So you can see a stack of the satellites that I actually worked on with the Earth in the background in the bottom right here. Before that, I was at the NASA Jet Propulsion Laboratory working on the Perseverance rover, which we just saw land. Back in middle school and in high school, I loved being a part of FIRST Robotics and the debate team. I ultimately went to University of Michigan, where I studied aerospace engineering. So today we're going to be talking about two major branches of space exploration. One, exploration done with robots, and two, exploration done with humans. So first, I want to talk robots. In the past 60 years, we have sent science missions using robots to every planet in our solar system. What you see here is a winding map of all the flight paths these different missions have taken after they were launched from Earth back here. And my goal here today is not for us to analyze every single mission, but I do want to point a few things out. So here you can see Earth, and you can see a high concentration of circles around us. And these are all the satellites that we've launched into orbit around our planet. And they give us utilities like GPS, satellite TV, satellite radio. They also provide really important information about the Earth. When you think of NASA, you may think of looking out into the furthest parts of space, but much of what NASA does is actually centered on understanding our own planet. So for example, these satellites around Earth, some of them are responsible for taking measurements that allow us to forecast weather and track severe storms. So whenever you see on the Weather Channel a snow forecast, that's brought to you by one of these satellites. We can also here see missions swirling between the moons of Mars, Jupiter, Saturn, and even inspecting our favorite dwarf planet out here, Pluto. So here is my first question to you all. What are some reasons you can think of to study outer space? Why is it cool or interesting or important? And please share your answers if you can in the chat. And no wrong answers here. There's a lot of cool things to think about. And I'll give you a minute. Totally. It is very cool. It is very big. And it is very awesome. You guys are nailing it. Yeah. Cool to learn about how all these planets are different. Space has a lot of mysteries. Absolutely. Make sure asteroids don't hit us. Yeah. Spin off tech. Look for different species, look for alien life. Yeah. Yeah, you guys are pointing out some fantastic reasons. And a few reasons come to my mind when I think about this question as I'm doing my work. So one of them is exploring space helps us understand our solar system in ways that are just not possible from the surface of Earth. So on the left here, you can see a picture of Pluto that was taken from a telescope on Earth. And it's really nothing more than a fuzzy ball of pixels. In contrast, here you can see a photo of Pluto that was taken from the New Horizons spacecraft that flew by in 2015. And from this flyby, we had turned what had been a fuzzy ball into a world covered in frozen water mountains and geologic activity. We suddenly could understand and study this planet that was 3 billion miles away in a detail that had never been possible had we not sent a mission out there. Space exploration also helps us understand the way stars evolve. Our sun is so important for the ability of life to exist here on Earth with its energy, its warmth, its light. And by looking out into space, we can better understand how our sun evolved and what possible futures may lay ahead for our solar system. On the right, you can see a nearby star system that is close to going supernova. Now, supernovas are massive collapses of stars in which all the nuclear fusion that normally keeps a star glowing and growing stops. And the star collapses in on itself in a matter of seconds at over 100 billion degrees Fahrenheit. During this collapse and subsequent explosion, the star ejects mass outward in a massive display. And we've come to the amazing discovery from our observation of space that all of the elements on the periodic table that make up our universe that are not the very simplest, hydrogen and helium, were made inside stars and distributed by supernova. This includes the carbon that makes us up, the heavy metals in our phones and electronics and jewelry, the oxygen and nitrogen in our atmosphere. All of this came from deep space. Now, sometimes space can seem so big and so distant that it's challenging to see how understanding it could improve our everyday life. But as someone pointed out in the chat, we've come to realize that asteroid impacts can pose a very real risk to life on Earth. NASA and other international space agencies have started launching missions to develop techniques for redirecting or moving asteroids that pose a risk of hitting Earth. And one of these is the Double Asteroid Redirect Mission, or DART, which will be launching in July. And this mission is really cool. It's going to shoot a spacecraft into an asteroid and with the collision, just barely scooch it into a whole new orbit. This particular asteroid is not at risk for impacting Earth. However, other potentially hazardous asteroids have been identified that this technique could be used on if proven successful. Now I want to ask you guys another question. What kind of systems or parts do you think a spacecraft needs in order to operate and communicate. As you can see here, they come in all sorts of different shapes and sizes, but they do have some common features. So let me know your ideas in the chat of what you think these spacecraft need. Yep, solar panels, an engine, metal. There's usually a lot of metal, that's true. Propulsion, awesome. Way to keep energy, so maybe thermal. Weird stuff, lots of weird stuff. Cameras, a comm system, yeah. Need something to talk to ground control, absolutely. Awesomeness, secret sauce right there. You guys are a fun group. I love these answers. Keep them coming. Radar, cool. So yeah, you guys have been pointing out a lot of great features. So first of all, your spacecraft needs some way of making power. And as was pointed out, solar panels are a great way to do so if you're close enough to the sun. So if you're close enough to the sun, you can use solar panels on these satellites like you might have on your homes. On the left here, you can see the Juno spacecraft, which is currently exploring Jupiter, and it has 3 30-foot long solar panels. I worked on this kind of space solar when I was at SpaceX, and I'll talk a bit more about that later. Now, if you're too far away from the sun, you need to come up with some other way of getting power. The New Horizons spacecraft, which we mentioned earlier, that went all the way to Pluto, used a nuclear generator for power, and that converted heat from radioactive decay into electricity. And you can see that little nuclear power source here. This same type of nuclear power was on board the Mars rover that we just launched. Now, once you're powered up, you need some way of communicating with Earth. All of these satellites have dishes and antennas so that they can send data to Earth and receive instructions back. Now, the real stars of the show are the science instruments that these satellites have on board, because this, after all, is why we're launching these missions in the first place. These instruments are what are completing the measurements and making the observations that are needed to answer the fundamental science questions of these missions. So, for example, you can see a cluster of these instruments peeking out from the New Horizons spacecraft here. Now, these instruments are usually quite picky, and they want to be kept at usually a very specific temperature. And because of this, spacecraft often have what we call thermal blankets, which is this gold foil that you see here. And this keeps all of the instruments and parts on board at just the right temperature. Now, oftentimes you want a satellite or a robot to be able to move itself around so it can make changes to its direction or its position. On the right, you can see the Dawn mission, which we sent to study multiple asteroids, and it has an ion engine on board. Ion engines use super fast, glowing charged particles to propel themselves through space. And these are really wild. You can see them glow with your naked eye. I've been there for some of these tests, and it's absolutely beautiful. Now, not visible, but equally important is all the software and all the electrical wiring that runs like a nervous system throughout all of these vehicles. Now that we've talked about robotic missions more broadly, I'd like to discuss some of the amazing ones this past year. And I want to start with the Mars 2020 or Perseverance rover. I saw in the chat that one of you had your names on the rover, and that is so cool. As some of you may know, this rover successfully landed a few weeks ago, back on February 18th, and we've already started to get some amazing photos back from the mission. Here, you can see the rover before launch in the clean room at the NASA Jet Propulsion Laboratory in Pasadena, California. It was built and assembled with careful concern to not contaminate it with Earth-based life. And what was the reason for this? Well, Perseverance will be looking for signs of ancient life on Mars, and we don't want to confuse it with something we accidentally brought with us. It has 7 science instruments on board that will be analyzing the chemicals and minerals on Mars in the search for these life signs. And the rover also has a very exciting passenger on board, a robotic helicopter, which will actually be taking off on its first flight tomorrow. So here you can see all of the instruments that are on board this rover. And I want to point out 2 of them in particular. One is the MOXIE payload in the bottom left here, and the onboard helicopter, Ingenuity. So starting with MOXIE, MOXIE is what I worked on when I was at NASA. And it is a tech demonstration to show that we can convert the Martian atmosphere into breathable oxygen for humans. This ability will be very important if we want astronauts to be able to work on Mars for hopefully a long period of time. We don't want them to be relying on shipments from Earth every time they need a bit more water or a bit more oxygen. We need technology that can get these resources from the local environment. And MOXIE is a very exciting step in that direction. Now I want to talk about Ingenuity, that little helicopter. It will be the first ever demonstration of flight on another planet, and it's scheduled to take off on its maiden flight tomorrow. Get hype, super cool. This helicopter is very lightweight, weighing only about 4 pounds. Here you can see it in the clean room back on Earth, and it has 4 carbon fiber rotor blades for generating lift in the very thin Martian atmosphere, and a solar panel on top for producing power. During the trip to Mars, Ingenuity was tucked under the belly of the rover, and this photo shows Perseverance tightly packed into its heat shield on Earth, with Ingenuity boxed in red, ready for the ride. Here is a compilation of photos that show Ingenuity being lowered to the surface. So first you saw its protective shield pop off, and that protected it from debris and rocks as the rover was landing. And next you can see it rotate into place with its 4 landing legs locking into position. Now it can stand on its own 4 feet. Perseverance has now driven away from Ingenuity to give it some space. It's now charging up with its solar panel and getting ready for takeoff. For its first demo, Ingenuity will hover about 10 feet above the ground for around 30 seconds. If it works, it will later try to fly further and higher. I am so excited to see how this performs, and you should tune into NASA TV tomorrow for the mission updates. I now want to talk about the landing itself, and I hope some of you had the chance to watch the event live back in February. The car-sized Perseverance rover descended to Mars via a crazy sequence of precisely timed events, ultimately being lowered to the surface via a hovering stage called a sky crane, which you can see in the top right up here. This same method was used back in 2012 with the Curiosity rover, but this time we got pictures. Here is an amazing picture taken of the rover from the sky crane with the Martian surface in the background. And here you can see the rover with its 6 wheels hanging from cabling as it descends towards the Martian surface. Here is a picture that the rover took up at its own parachute. And I want to point out a little Easter egg that NASA left for us. Using binary code, NASA engineers encoded 2 secret messages into the coloring of the parachute. Dare mighty things is written in the inner rings, and this is JPL's motto. And on the outer ring, you can see the GPS coordinates for Pasadena, California, where JPL is located. After the landing on February 18th, scientists eagerly waited to get down their first pictures and data from the rover. Here you can see some of the very first images that were received by Mission Control. And knowing that all of this has happened in just the first few months of the mission, it'll be so exciting to see where this mission takes us and what we learn. Now I want to shift gears and talk about a mission of a slightly different flavor, OSIRIS-REx. And this goes back to what I'd been talking about earlier in terms of missions to protect Earth. The purpose of OSIRIS-REx is to collect and return a sample from the near-Earth asteroid Bennu, which is the first time NASA has ever tried to return a sample like this. Bennu is considered potentially hazardous because it is at high risk for impacting Earth in the late 22nd century, so about 150 years from now. This mission will help us study the asteroid so that we can better address it if it becomes a threat. OSIRIS-REx was launched 4 years ago, and this past October, it successfully got its sample. Now OSIRIS-REx is waiting for perfect alignment between the Earth and the asteroid before it sets off to return the sample via a parachute to a test site in Utah. Now, I find this to be a truly remarkable example of precision in space exploration, that we can use our understanding of the movement of these asteroids and planets to accurately launch a satellite from Florida, send it to pick up a sample 200 million miles away from an asteroid barely a mile across, and then deliver it back to Utah. So once it comes back, depending on how much fuel it has left, OSIRIS-REx might be assigned to go to a whole new place and check out a whole new science target. Now I want to talk a bit more about that actual touch and go event during which the satellite retrieved its sample. So on the left here, you can see an actual video taken by OSIRIS-REx during the moment of impact. So using this leg that it has on the bottom, OSIRIS-REx churned up this cloud of rock and dust. And from this cloud, it gathered 2 ounces of sample that it's now going to return to Earth. Now that it has the sample, all that's left to do is wait for OSIRIS-REx to come home. Even though it's been a super cool year for robotic missions, it is certainly not the peak. There are a lot of missions coming up that we have to look forward to, including the James Webb Space Telescope, DART, which we talked about earlier, Psyche to the asteroid Psyche, Europa Clipper, and Dragonfly. And 2 of the missions on this list, Europa Clipper and Dragonfly, are 2 potentially habitable moons that we consider top candidates for supporting life in our solar system. Europa is one of Jupiter's moons, and there's a picture of it here. It has always been one of my favorites. It is an ocean world covered in salt water with a frozen crust of ice. In total, it has twice the amount of liquid water than all of Earth's oceans combined. Our hope is that within these oceans, we might find microscopic or other forms of life. So Europa Clipper will be a mission to map out the surface of Europa so that we can pick the best landing site for a lander that is scheduled to launch a few years later. I now have another question for you all. I'd like to think about how we design these missions. which starts with the question of what are some differences between the Earth environment and outer space? So let me know your thoughts in the chat. Yeah, space is cold, no gravity. No air. Yeah. Radiation. Absolutely. Vacuum. Things can't grow. Cold. Very cold. Awesome. Oh, Sophie loves space. I do too, girl. You float, so related to gravity or lack thereof. Awesome. So yeah, you guys have pointed out some great differences. And as you have guessed, space is an absolutely brutal place. Before we even get to space, our sensitive instruments and fragile satellites have to survive the ride up on the rocket. So during this ride, the spacecraft will experience 22 Gs of vibration from the engines and launch. To put this in perspective, 1 G or 1 gravity is what you're currently experiencing sitting in your chair. 5 Gs is what you might feel on a roller coaster. Fighter pilots trained to be able to work in 9 Gs for a small period of time. Above that level, the heart can't pump enough to bring blood to the brain, and humans pass out and eventually die. Our sensitive hardware has to survive more than double that amount of force just to get to space. Once it's actually there, it has to deal with huge temperature swings, the vacuum of space, and high radiation levels. On the right, you can see the temperature difference between the sun-facing side of Mercury, which is at almost 800 degrees, and the cold side that is in shadow, which is negative 300 degrees. So if we want to send a satellite to Mercury, we would need to build parts that could survive an over 1,000 degree temperature change, or develop a way to keep our parts at just the temperature we want. The satellite also has to contend with all the odd effects of being in vacuum, as well as charged particles beaming from the sun. Most systems we design for Earth would not be able to handle this. For example, let's imagine we send an iPhone to space. What would space do to the iPhone? Well, right off the bat, the vibration during launch would likely shatter the screen and other fragile electrical components inside. To prevent this, we could cushion the iPhone against the vibrations to give it a softer ride. Once it's up there, the screen and other components, such as the silicon chips inside, might break due to the big temperature changes. On the left, you can see a picture of an unfortunate iPhone that was dunked in a tank of liquid nitrogen, and this exposed the phone to about negative 300 degrees. This caused fractures across the phone screen as the materials violently contracted. On the other hand, if the phone gets too hot, so say is on the sun-facing side of Mercury, solder, which holds together many of the electrical joints inside the phone, could melt. We could prevent this by insulating the phone using a material like that yellow thermal blanket we saw earlier on New Horizons. Now, without our nice atmosphere here on Earth to protect it, the phone would also experience a lot of high energy particles from the sun. And this could wreak havoc on the electronics of the iPhone, causing memory to be boggled or static charge to build up that could zap the components. A solution here would be to shield the parts from radiation. Think of when you're getting an x-ray at the dentist or the doctor, and they give you a lead smock to wear. This is to protect your fragile internal organs using a layer of high density metal, or in this case, lead. That same idea can be applied here to protect the sensitive electronics by putting a shielding layer of metal around them. Once we've taken our best stab at designing a spacecraft that we think can survive space, we want to make sure that it actually can, since repairs and changes are usually not possible after launch. And the best way to do that is to test. Here you can see the descent stage of the Mars rover, so that's sky crane part, in a space simulator chamber at NASA JPL. This chamber simulates space by recreating the temperature and vacuum environment of space so that we can make sure that the vehicle performs as we expect before we launch it. Now, we do this sort of testing for all sorts of environments that we expect a spacecraft to see on orbit. And here are some more examples. On the left, you can see me performing shock testing to simulate pyro-explosive events on orbit. And this was a wild setup. We shot a bullet about yay big out of an air pressure cannon into our hardware, which in this case was a few cable connectors I was testing for the rover. And you can see them on this gold block here. This bullet sent about 2,000 Gs into the hardware in a quick impulse. Now, remember how I said 10 Gs could kill a person? This is 2,000 Gs. On Mars 2020, we used explosive bolts to separate the descent stage from the rover so that once the rover was landed, the stage would cut away. This test helped us make sure that all the components near those explosive bolts could survive the explosions. In the middle here, you can see the satellite that we sent to Mercury undergoing vibration testing to make sure that it could survive the rocket launch. So here you can see the satellite installed on a table, and this table would shake so quickly it almost didn't look like it was moving, and that would induce vibrations into the satellite. Now, not only do we get vibration from the various engines igniting or the rocket stages separating, the launch is so loud that we get destructive vibrations just from the sound waves. On the right, you can see the Orion crewed capsule surrounded by 1,500 speakers to make sure that it can survive the acoustics of launch. I now want to talk a bit about the work that I did at SpaceX. So while at SpaceX, I worked on the solar arrays to provide the Starlink satellites with power. So they were each 25 feet long, and you can see them in a rendering here. There are currently over 800 satellites on orbit as a part of this mission, and more satellites are launched every few weeks. As you can probably imagine, solar cells are generally very fragile, and they don't much like being crushed or bent. So the launch environment is pretty rough on them. I would perform a type of testing called electroluminescence testing to determine how damaged a solar cell would become from launch. Normally, a solar cell converts light into an electric current that can then be used to generate power. However, here's a neat trick. If you reverse that and instead put current into the cell, it will produce its own light. I used this property to visualize areas that were damaged because areas of a solar cell that don't glow are cracked. On the right, you can see what a solar array would commonly look like after vibration testing, with all those black areas being parts of cells that could not produce power anymore. After seeing results like this, we would revisit the design and change things to make them more hardy. So we've talked all about the amazing recent robotic missions and how we design and test them to make sure they're successful. But how about human exploration? What are some reasons you can think of to send human beings into space? To explore. Humans want to go places, absolutely. You don't have to program humans. This is true. So they can describe what they're seeing. Real life Star Trek. Oh, that would be very exciting. Easier to control. Maybe. They want to get close to the sun. Real life Star Wars. Yeah. A lot about the human experience and human ingenuity. Yeah. Providing information. Yeah, that is detrimental to human life. Nice. Spacewalks. Oh yeah. So yeah, you guys are coming up with some great options. And there's a few things that come to my mind, which many of you guys touched on. First of all, it's extremely important to understand how the human body responds to a low gravity environment. And there's actually a whole field of study for this called bioastronautics. From the missions we've already sent, we've discovered that astronauts experience physical changes when they spend time in space. Because their bones and muscles don't need to fight the force of gravity, their bone density goes down and their muscles tend to weaken. To fight this, astronauts need to work out with special pieces of equipment, like you can see here with an astronaut running on the treadmill, and that apply pressure to their muscles and bones to simulate gravity to help combat these effects. But other strange things happen to astronauts, like the shapes of their eyes deform when they're in space, which can impair their vision. If we want humans to spend longer periods of time in places like the moon and Mars that have reduced gravity, we need to figure out ways to counteract these negative effects to make sure that those humans can stay healthy. It's also very helpful to send humans to space because of their complex problem-solving skills. Robots are extremely good at doing extremely specific things. However, if you throw something unexpected at them, like soil that's a little too packed or a rock that's a little too steep, you can get caught between a rock and a hard place. Humans, on the other hand, could change the angle of their shovel to dig through the stubborn soil, or could use improvised tools to move the rock. That flexibility is very helpful when you don't quite know what to expect in a new environment or on a new planet. And lastly, humans have the ability to create science outposts like what we currently have in Antarctica. Before we even think about fully colonizing a new planet, if we were to even just create smaller science outposts on the moon or Mars, we could use these as a launch point for a whole slew of new exploratory missions. So bring alive a new chapter like Star Trek or Star Wars. Now, anyone here know what this space habitat is called that's orbiting above us right now? Yeah, ISS. So this is the International Space Station, and it has been continuously manned by a crew of astronauts for over 20 years. It is orbiting above about 240 miles up above Earth's surface, and it contains a bunch of segments or modules for astronauts to live in and conduct experiments in. This past year saw us hit a huge milestone in terms of crewed exploration, the SpaceX Demo 2 launch. This mission, which launched in May of this past year, saw astronauts launched aboard a US rocket for the first time since the end of the space shuttle era, which was 10 years ago. It was also the first time that a private company, not just a national space agency, sent astronauts to the ISS. This mission was a huge success. Here you can see the astronauts, Bob and Doug, in front of the Dragon capsule, which they safely rode to the ISS and back to Earth after spending 62 days on orbit. I've now put together a brief highlight reel from NASA coverage of the mission to give you a sense of the event. So everyone turn up your speakers and let me know if you have trouble hearing this.
Dragon is in countdown. FTS is armed for launch.
3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA. Go SpaceX. Godspeed, Bob and Doug.
America has launched. So rises a new era of and with it the ambitions of a new generation continuing the dream.
Well, everyone, welcome aboard Dragon. My name is Doug. Next to me is Bob. You probably know him.
I think I was requested to do a backflip. I'm going to kind of do a side spin, which is a little bit of a permutation on that request. We do have an Apatosaurus aboard. We both have two boys who are super interested in dinosaurs. And we collected up all the dinosaurs between the two houses, and Trimmer, the Apatosaurus, got the vote from the boys to make the trip into space today with us. The approach has resumed. Dragon closing in. We're inside 20 meters. You can see the surface section of Draco is just doing all these very small, minor attitude corrections. Really, the autonomous docking system at work. Wow.
We have Bob Bankin from SpaceX Demo 2 mission entering the International Space Station. Followed by Doug Hurley.
So yeah, I was working for SpaceX at the time of this launch, and it was incredibly exciting to see the successful mission and to see the astronauts up on the ISS and hugging. It was, yeah, very emotional. After the successful launch of Demo 2, SpaceX received the green light to be a taxi for transporting astronauts up to the ISS regularly. They most recently sent up a crew this past November, which included 3 astronauts from NASA and 1 astronaut from the Japanese space agency, JAXA. These astronauts are soon to be replaced by the next crew, which will be launching from Cape Canaveral in Florida this upcoming Tuesday. So be sure to watch that. In total, each group of astronauts will spend about 6 months on station before they're replaced by the next crew. To support all these missions, NASA has developed a bunch of technology that has found useful applications in our daily lives. Can you guys give any examples? Yeah, someone in the comments wrote about how docking had been a big challenge for the previous mission, and that's absolutely true. Post-it notes, Mylar, navigation, yeah. GPS, absolutely. Micro, small electronics, yeah. This drove a lot of miniaturization. Water guns. Solar, yep. Memory foam, yep. Yeah, you guys are nailing it. Lots of ideas for sci-fi. Thermal protection, yeah. Wi-Fi. Cool. Yeah, you guys, oh, freeze-dried fruit, absolutely. Oh, you guys are coming up with some beautiful examples. And yeah, so NASA has developed hundreds of technologies that we use across all sorts of different fields, spanning food science to navigation to new materials. And as several of you pointed out, NASA helped develop high precision GPS, for example, which is now a bedrock of how we navigate in our cars and our planes using Google Maps. Memory foam was developed to give astronauts more customizable seats. Artificial heart pumps were derived from space shuttle fuel pumps. Invisible braces were invented by NASA as a material for a rocket coating. And solar energy was tied to our earliest space development efforts. Tortillas are a fun example. So tortillas are a favorite of astronauts because they don't produce crumbs like bread that can get stuck in the onboard ventilation system, one of those issues you have in low gravity. Unfortunately, especially for longer missions, astronauts had the issue of these tortillas expiring early on. So NASA invented shelf-stable tortillas and flash freezing techniques to help food stay fresh for longer and months at a time instead of days. Now you can find NASA tech in your local grocery store. I'd now like to discuss a mission that I'm currently working on, Illumity. And this mission will use lasers to make data download speeds much faster from the ISS to Earth. Currently, way more data is produced from experiments performed by astronauts on the ISS than we can easily get to the ground. Instead of using radio waves like we've traditionally done, this new technology will beam the data in light to Earth. So think of it like Morse code, where information is encoded in the turning on and off of sound. This new system encodes information in the turning on and off of light. To get a sense of the performance improvement, let's imagine that the astronauts really want to share the Lord of the Rings movie trilogy with ground control. With the current system, it would take about 1.5 hours to download the movies to Earth from the ISS. With this new optical communications system, it will take less than a minute. On the left, you can see astronaut Christina Koch performing one of the many experiments on the ISS. And she has the record for the longest spaceflight by any woman, staying up on the ISS for almost a year. And she is currently a candidate for NASA's upcoming Artemis mission. Artemis is NASA's upcoming mission series to send astronauts back to the moon. Artemis 2 will be the first launch that will have a crew on board, and it's scheduled to launch in 2023. It will take off from Cape Canaveral in Florida with a crew of 4 on board and complete 1 lunar flyby before splashing down in the Pacific Ocean. I'm currently working on a communications terminal that will fly on Artemis 2 called O2O. It is very similar to Illumity in that it will encode information with light, but this time it will go on the outer rim of the Orion crewed capsule, which is shown here. We will use O2O on this mission to get ultra high definition video from the moon, as well as to improve science data transmission throughout the mission. So I have one last question for you all. True or false? You have to be an engineer to work on space exploration. False, yes, all the falses. All the falses, all right. False. I feel like it is the greatest myth of space that you have to be a rocket scientist to contribute. Space exploration requires a huge spread of disciplines and interests to make it happen. We need doctors to make sure the astronauts stay healthy. We need graphic designers and artists to make incredible mission graphics, like for the Mars missions. We need technicians, machinists, electricians to actually build the spacecraft. We need writers to record data and advocates to help inform policy decisions. We need business people to help us pick the parts, project managers to run the teams, lawyers to file patents, and then, of course, every type of engineer under the sun, including ones working on electrical systems, mechanical, coding, thermal. Space is a massive undertaking that draws on skills and interests from every corner of human achievement. Regardless of your interests, there is a place and a need for you here. So thank you all for going on this crazy journey with me. I'd love to answer any questions you may have on these topics or on my career. Also, please feel free to reach out or keep in touch on my email. So thank you all for being such an engaged audience.
Ariel, thank you, thank you, thank you. Colin, why don't you ask your quick question, then I want to say a couple words before we move on to our next thing. Can you unmute? Maybe. There you go. Go ahead, Colin.
I wasn't able to type through the entire thing, but what days does Elon Musk go to SpaceX?
So he's around a lot. So he does have to juggle it with his other companies as well.
Yeah,
but
like Tesla, Neuralink, the
Boring Company. Oh yeah. So he is very, very present with SpaceX though, and he spends a lot of time in Texas working on the Starship program, which is also gearing up right now. So there's a lot of really cool efforts being made for SpaceX to go further and not just go to the ISS. And so he's spending a lot of time down there working on that right now.
Yeah, because when I saw you were working at SpaceX, I was doing a presentation on him on May 14th. So
wonderful.
I didn't know what days he goes to because I forgot to look that up.
I probably wouldn't focus on that because the exact days change every week, right? It's just kind of, that's like a little detail, but overall, he's putting a lot of time into SpaceX.
I think he has like 8 different jobs, but
busy dude.
Well, Colin, think about it. When you go to college and all the things you can do associated with space, and if Elon Musk is one of your people you look up to, just think about all those things you can aspire to be. So, Ariel, tell us a couple things. You don't live in Denver, do you?
No, I'm natively from Denver. Family is still all there, but I am in Boston right now.
I knew there was the connection, and so where did you? So you grew up here, and then you went to high school out here?
Yep. So I went to Ramah, Rocky Mountain Hebrew Academy, K through 8, and then I went to Cherry Creek High School for high school. And then from there went to University of Michigan, and I'm currently in Boston for my MIT work.
That's what I thought. Well, I wanted to say thank you, and to all of you kiddos who stayed on and listened to this amazing presentation and what you can aspire that, not only did Ariel grow up in Denver, she's Jewish and has all these connections to all of us. And so if you guys ever have questions and so forth, you can reach out to Ron or myself or your teachers, and we can send her those questions and move forward. Carly is on here, and I know you spoke with Carly. And again, Carly, did you want to say anything before we move on to the next program? She's in the middle somewhere. You're muted. Oh, I think she's good. But Ariel, thank you. We're going to be in touch with, she's unmuted.
I just wanted to say how cool to get to see this and to really see what people do in such amazing careers and all of the incredible things we can do when we put our minds to it and we work so hard. And so Ariel, thank you so much for being with us and for just showing us what incredible opportunities are out there for us all the way in space too.
Yeah, you are so welcome. And as my mom pointed out, I actually went to Temple Sinai for preschool. So the connections are even earlier.
There you guys go, for those of you who went to preschool here as well. So it's amazing to have somebody within our community that grew up in Denver to be connected to in such a cool manner. So
Yeah.
Anything else that anybody has? If not, we
want to make
are
sure
gonna do-
everybody
All
saw
right, thank you
Ron's
very
note,
much.
4th through 6th grade. You are going to head right to your classes.